When an enterprise network is compromised, the entry point is rarely faulty physical hardware. The most devastating exploits usually start with a single flawed logic statement written by a developer trying to save time. For proof, look at the Y2K bug. Back then, programmers needed to save valuable system memory. To do that, they wrote programs that shortened 4-digit years into 2 digits. 1998 became 98. This slide illustrates the exact calculation that caused the panic. When the year 2000 hit, computers would read it as simply 00. Suddenly, an equation determining age or calculating interest would output negative numbers, breaking the underlying math. It was a minor code optimization that accidentally created a global vulnerability. Welcome back to the channel. Be sure to hit like, subscribe, and check the description below for links to today's code snippets. In our last chapter, we mapped out the target network using enumeration. Today, we are focusing on how to actually communicate with those targets by learning the programming languages they were built on. If you want to defend a system or reverse engineer the exploit an attacker left behind, you have to be able to read the language it was written in. Many common attacks on operating systems and applications succeed because the code wasn't written securely. Traditional programming education prioritizes functionality and speed, leaving developers unaware of how their code might be manipulated. The modern industry solution to this is a framework called DevSecOps, combining security, development, and operations. Instead of building software and patching the holes later, security protocols are baked directly into the code from day one. This slide breaks down the core concepts of programming logic: branching, looping, and testing, the BLT. Branching takes you from one functional area to another. Testing verifies if a condition is true or false, dictating if that branch is taken. While real-world codebases can be incredibly complex, these three concepts provide the structural base to begin navigating the logic of any script you encounter. This slide details the origins of the C programming language, created back in 1972. C is a powerful, memory-based language that remains essential for understanding deep operating system vulnerabilities. Looking at this classic Hello World script, we see the anatomy of a basic C program. Because computers don't understand English text, this relies on a compiler to convert the source code into the executable binary the hardware runs. Moving from the deep logic of the operating system up to the surface layer, we encounter the web framework, HTML. HTML builds the websites you visit every day, but it is strictly a formatting language, not a logical programming language. It tells the browser how things should look, not how to process complex math. As a defender, you still need to read HTML fluently. Attackers frequently disguise malicious scripts and payload delivery mechanisms within innocent-looking web tags. C builds the core architecture. HTML builds the visible surface. Attackers probe for the weakest link, so analysts protect the entire stack. To operate at scale, security teams rely on scripting languages like Perl. Hackers use Perl to quickly generate malicious bots, but incident responders use it to automate defensive monitoring and perform repetitive security tasks. Python is another critical tool, featuring a highly interactive shell known as the REPL: read, evaluate, print, loop. You can type a command into the terminal and Python executes it instantly, ideal for rapid security testing on the fly. This snippet of a C++ class shows object-oriented programming in action. Instead of writing long, linear scripts, developers organize massive environments by grouping related data and functions into individual classes and objects, like this one defining an employee. Here we see an overview of Ruby, another powerful object-oriented language. This one is highly relevant to penetration testers because it forms the backbone of Metasploit. If you want to customize an advanced exploit in Metasploit, you need to read and modify Ruby code. By utilizing these scripting and object-oriented languages, security professionals can move past clicking buttons manually and become highly automated, scalable defenders. Mastering these syntax rules dictates your trajectory in the job market. Security operations centers are full of analysts who know how to run automated software, but when that software fails to stop a new threat, those analysts get stuck. Knowing how to code is the threshold that separates the tool user from the reverse engineer. An analyst merely understands how the software works. An engineer understands exactly how to build the logic powering it. Thanks for watching. If you want to dive deeper into how these attacks are investigated post-breach, check out our Digital Forensics playlist, or head over to our Network and Systems Security series. In our next episode, Chapter 8, we will take the programming basics we learned today and apply them directly to discovering vulnerabilities inside desktop and server operating systems. Until then, look under the hood of the tools you use every day. Stop just running scripts and start mastering the logic behind them. Stay secure.